Hello, we're here together to explore one of the most fascinating forces in the universe. Have you ever wondered how we're able to see the world around us? What really happens when light touches our eyes? Take a deep breath and make yourself comfortable. We're about to embark together on a journey through the most beautiful mystery that surrounds us, the light that paints every second of our existence. I want to invite you to something special. Imagine that you can close your eyes and still continue seeing. Not with the eyes of the body, but with the eyes of imagination, curiosity, the soul. Because today we're going to talk about something that's so present in our lives that we almost forget its existence: light. But we're not going to talk about light merely as something that exists. We're going to discover how it is, literally, the invisible artist that paints every second of our lives. Every color you see, every shadow that's cast, every reflection that dances on water, all of this is its work. This mysterious force that travels through space at a speed our minds can barely comprehend. Have you ever stopped to think that at this exact moment, while you hear these words, billions of photons are dancing around you? They ricochet off walls, cross through air, touch your skin, enter your eyes, and transform into images, colors, shapes. It's a cosmic ballet happening on a microscopic scale, and you are both spectator and participant. But there's something even more fascinating. The light you see now is not just light. It's information, it's history, it's memory traveling through space. Each beam of light carries with it the signature of the place it came from, the temperature it encountered, the materials it touched. Light is a silent messenger, and the entire world is its love letter to us. Have you ever wondered why the sky is blue, why sunsets are red? Why your hands seem to have color when, in reality, they only reflect certain wavelengths of the light that touches them? These are questions we'll explore together, but not just as scientific curiosities. We'll treat them as doors to a deeper understanding about the nature of reality. What if I told you that light doesn't just illuminate the world, but literally constructs it? That without it, there would be no color, no form, no perception of distance, texture, movement? Light is the painter of the universe, and we are its living canvases, constantly being redrawn with every blink of our eyes. In this journey, we'll discover that light is much more than we imagine. It's quantum physics and poetry, science and art, the microscopic and the cosmic united in a single dance. We'll see how it connects us with the most distant stars and the closest atoms, how it reveals secrets about the universe's past and humanity's future. So, breathe deeply. Let your muscles relax. Allow your mind to open to mystery, because we're about to embark on an adventure that will forever transform the way you see, well, the way you literally see everything. Close your eyes for a moment and imagine that you can hear light. Yes, hear it. Because light, my dear listener, is an invisible symphony playing constantly around us, music made of frequencies that our ears can't capture, but that our eyes translate into colors, textures, and shapes. Every color you see is, in fact, a note in this cosmic symphony. Red is a deep, profound note with a low frequency that vibrates approximately 430 trillion times per second. Can you imagine that? No musical instrument can produce such a high frequency, and yet this is considered the most base of visible colors. Rising up this chromatic scale, we find orange. Then yellow, the color of the sun, vibrating around 520 trillion times per second. It's a frequency that seems to awaken something primitive in us, an ancestral memory of the light that brought life to our planet. Have you ever noticed how yellow has this power to make us feel more alert, more alive? Continuing our journey through frequencies, we reach green. Green. About 580 trillion vibrations per second. It's fascinating to know that our eyes evolved to be most sensitive to exactly this frequency. Why? Because it's the predominant color of vegetation, the color of life on Earth? Our ancestors who could better distinguish variations of green had a greater chance of survival, of finding food, of avoiding camouflaged predators. Then comes blue, with its 670 trillion vibrations per second. It's the color of sky, ocean, infinity. And did you know that blue is one of the most recent colors in the history of human language? Many ancient cultures didn't even have a word for blue. They saw the sky, but described it as white or used the same word for blue and green. At the highest extreme of this visual symphony, we find violet, vibrating at approximately 750 trillion times per second. It's the color of transmutation, spirituality, transformation. It's no coincidence that so many mystical traditions associate violet with the sacred. But here's the truly impressive part. These frequencies we call visible light represent only a tiny fraction of the electromagnetic spectrum. It's as if we could hear only 7 notes of a cosmic symphony that contains trillions of notes. Below red, there are infrared frequencies, the light of heat. You can't see them, but you can feel them. It's the radiation that emanates from a bonfire, from your own body, from everything that has temperature. And above violet, there's ultraviolet radiation, invisible but powerful, capable of transforming your skin, sterilizing surfaces, revealing invisible secrets. Even further beyond, at lower frequencies, we find radio waves, which at this moment are passing through your body, carrying music, news, cell phone conversations. And at higher frequencies, we have X-rays capable of passing through your skin and revealing your bones, and gamma rays, so energetic they can come from star explosions billions of light years away. Have you ever stopped to think that you're constantly bathed by this invisible symphony? That, at this exact moment, radio waves from distant galaxies are passing through you, mixing with infrared light from your own heated body, with visible photons ricocheting off the walls around you. And most fascinating, each of these frequencies carries information. Infrared light tells about temperature, ultraviolet reveals chemical composition, X-rays show internal structures. We're constantly bombarded by an ocean of information, but our senses capture only a small fraction of this cosmic knowledge. Imagine if we could see all these frequencies simultaneously. The world would be a completely different place, a kaleidoscope of overlapping information. We'd see the heat of people's bodies as colored auras, radio transmissions as rivers of light crossing the air, cosmic radiation as a constant aurora in the sky. But perhaps our limitation is also a gift. Perhaps we see exactly what we need to see to navigate this world, to survive, to connect with each other. Visible light is the perfect window to the reality we inhabit. Billions of years ago, when the universe was young and hot, colors didn't exist. Can you imagine that? An entire cosmos plunged into primordial darkness, where only pure energy stirred in forms our minds can barely conceive. Color, this fundamental experience of our existence, had to be invented by the universe. In the first moments after the Big Bang, the universe was so dense and hot that even light couldn't travel freely. Photons, these particle waves that today bring color to our eyes, were trapped, constantly ricocheting between charged particles like people trying to cross a crowd too dense to navigate. Then, about 380,000 years after the beginning of everything, something magical happened. The universe cooled enough for the first atoms to form. Electrons joined with protons, creating hydrogen and helium. And, for the first time, light was liberated. This moment is poetically called recombination, but I prefer to think of it as the universe's first dawn. That first light still exists, you know? It's around you right now, invisible to your eyes, but detectable by our instruments. It's the cosmic background radiation, the luminous echo of creation, now stretched by time and the universe's expansion until it became microwave radiation. It's as if the universe had kept a photograph of its first moment of clarity, but there still wasn't color as we know it. That first light was almost uniform, a hot golden radiation spread throughout space. The first true colors were born inside stars, in those nuclear furnaces where simple atoms fuse to create more complex elements. Imagine a star as a cosmic laboratory of colors. In its core, hydrogen transforms into helium, releasing light that carries a specific signature. Each element created in the stellar furnace, carbon, oxygen, iron, gold, has its own way of interacting with light, its own color palette. When a star explodes in a supernova, it scatters these elements throughout the cosmos. Seeds of color that will incorporate into future stars, planets, and eventually you. The iron in your blood was forged in the heart of a star that died billions of years ago. The calcium in your bones was born in a cosmic explosion. You are literally made of colored stardust. But the true revolution of color happened when these elements began combining in complex ways. In clouds of cosmic gas and dust, on surfaces of rocky planets, in atmospheres of distant worlds, the first complex molecules began to emerge, and each molecule had its own way of dancing with light. Water, for example, absorbs certain frequencies of red light and reflects others, creating its characteristic blue translucent tone. Oxidized iron gives Earth its rusty red tone. Chlorophyll, that miraculous molecule, absorbs mainly red and blue light, reflecting green, and it was this selective rejection that painted our planet green and made life as we know it possible. Have you thought about this? The green color of plants isn't just an aesthetic matter. It's an evolutionary strategy refined over billions of years. Chlorophyll evolved to capture exactly the light frequencies that are most abundant in sunlight, but not all of them. It lets green pass because it doesn't need it. And it's this waste that creates the color we associate with life and nature. And then came us, humans, with our eyes specialized in detecting exactly these frequencies. Our color receptors, the cones in our retina, are like microscopic antennas tuned to three main channels: red, green, and blue. The entire spectrum of colors you see is created by the combination of these three basic signals in your brain. But here's the most fascinating aspect. The color you see doesn't really exist out there in the world. Color is an interpretation, a translation your brain makes of the light frequencies that reach your eyes. The rose isn't red, it reflects certain light frequencies that your brain interprets as red. Color is a collaboration between the physical world and your consciousness. This means color is both objective and subjective. It's objective because light frequencies are measurable, constant, universal. But it's subjective because the experience of color happens in your mind, created by the interaction between photons and your consciousness. You and I can look at the same object and have slightly different color experiences, and we'd never know. Now let's dive into one of the most beautiful and bewildering mysteries of physics, the dual nature of light. Prepare yourself for a journey that will challenge your intuition about reality, because light is, simultaneously, both a wave and a particle. It's as if it were a dancer who changes form depending on who's watching. Imagine you're observing waves on a tranquil lake. You see the ripples spreading in concentric circles, a disturbance in the fabric of water that propagates harmoniously. For a long time, scientists thought light was exactly like this, a wave in the fabric of space, an electromagnetic oscillation traveling at 300,000 kilometers per second. And indeed, light behaves like a wave in many situations. It can be reflected, refracted, diffracted. It can create interference patterns, where two waves meet and amplify or cancel each other. When light passes through a small opening, it spreads like ocean waves passing through a bay entrance. But then, at the beginning of the 20th century, something disturbing was discovered. Light also behaves as if it were made of small particles, discrete packets of energy we call photons. When light hits a metallic surface, it can knock electrons off that surface, but only if the light has enough energy. And this energy doesn't depend on light intensity, but on its frequency. It's as if light were a rain of small energy balls, each carrying exactly the right amount of energy for its specific color. A blue ball carries more energy than a red ball. An ultraviolet ball carries enough energy to break molecular bonds in your skin. That's why you get sunburned. Have you ever stopped to think about what this means? Every time you look at a lit candle, millions of photons are being emitted by the flame and traveling to your eyes. Each photon is like a small luminous message carrying information about the flame's temperature, about the elements that are burning, about the age of the light you're seeing. And here's the truly mysterious part. A single photon can, somehow, pass through two slits at the same time. It's the famous double-slit experiment, which even after decades still leaves physicists puzzled. If you don't observe which slit the photon passed through, it passes through both and creates an interference pattern. But if you try to observe, it chooses one slit and acts like a particle. It's as if light knows it's being observed and changes its behavior accordingly. This isn't science fiction. It's an experimentally verified reality thousands of times. Light is literally influenced by conscious observation. This leads us to a profound question. What is the role of consciousness in creating reality? When you look at a landscape, you're not just seeing passively. You're actively participating in creating the visual experience. Your eyes, your brain, your consciousness are collaborating with light to create the colors, shapes, depth you perceive. Each photon that enters your eye has gone through a unique journey. Perhaps it traveled for millions of years from a distant star, carrying information about that star's chemical composition, temperature, age. Or perhaps it was just born in a light bulb filament created by the agitation of electrons in heated metal. But regardless of its origin, each photon that touches your retina carries infinite potential for information. And when it interacts with the receptors in your eyes, something magical happens. Physical energy transforms into conscious experience. Light becomes vision, radiation becomes beauty, physics becomes poetry. Have you ever wondered how it's possible that electromagnetic vibrations transform into your subjective experience of seeing a sunset? How pure energy can become your visual memory of a loved one's face? This is one of existence's great mysteries, the bridge between the physical world and the world of consciousness. And perhaps it's exactly here that light's true magic resides. It's not just a form of energy or information. It's the medium through which the universe becomes conscious of itself. Through your eyes, through your perception, the cosmos contemplates its own beauty. Have you ever woken up on a clear morning and wondered why the sky isn't green, or purple, or transparent like glass? The answer to this seemingly simple question leads us to one of our planet's most sophisticated and constant laboratories, Earth's atmosphere. Imagine the atmosphere as a giant filter, a chemical and physical laboratory that never stops working, processing trillions of photons every second. It's here that sunlight, which reaches us as a mixture of all colors, is separated, filtered, scattered, and transformed into the colors we see in the sky. When sunlight enters the atmosphere, it encounters billions of tiny molecules, mainly nitrogen and oxygen. These molecules are much smaller than visible light's wavelength, and this creates a fascinating phenomenon called Rayleigh scattering. It's as if each molecule were a small prism that prefers certain colors. Blue light, with its shorter wavelength, is scattered much more intensely than red light. That's why the sky is blue, not because the air is blue, but because blue light is thrown in all directions by atmospheric molecules. When you look at the sky, you're seeing all this scattered blue light arriving at you from all directions. But here's something even more poetic. The blue of the sky you see isn't the blue I see. Depending on air humidity, pollution, altitude, season, the sky presents different nuances. Each sky is unique, like an atmospheric fingerprint of the exact moment you look up. And when the sun sets, the atmosphere becomes an impressionist artist. Sunlight has to cross much more atmosphere to reach you, and on this long journey, practically all blue light is scattered away. What remains are the reds, oranges, and yellows, the warm colors that paint the sky at day's end. Have you noticed that the most spectacular sunsets happen when there's a bit of pollution or dust in the air? That's because these additional particles create even more scattering, transforming the sky into an even more dramatic canvas of colors. It's ironic, isn't it? Pollution, which so harms our atmosphere, sometimes creates the most beautiful sunsets. But the atmosphere doesn't work alone. It collaborates with clouds, these sculptures of water vapor floating in the sky. Clouds are like giant screens where light projects shadows, reflections, and gradients. Light that passes through a cloud is softened, diffused, transformed into something gentler to our eyes. Have you ever lain on the grass watching clouds and noticed how they seem to glow from within? That's because sunlight is ricocheting between water droplets, creating internal luminosity. Each cloud is like a natural lamp, gently illuminated from within. And after rain, when the sun appears between clouds, the atmosphere gifts us with one of nature's most magical spectacles, the rainbow. Millions of water droplets suspended in air transform into tiny prisms, each one separating white sunlight into its component colors. But here's the rainbow's most beautiful secret. It doesn't really exist out there. Each person sees their own rainbow, created by droplets in a specific position relative to the sun and their eyes. The rainbow you see isn't the same one the person next to you sees. It's a personal, unique experience, created by the collaboration between light, water, and your position in space. And at night, when the sun hides, the atmosphere continues working. It filters moonlight, creating that silver luminosity that transforms the landscape into something almost dreamlike. Moonlight is actually reflected sunlight, but the atmosphere processes it differently, creating a completely new ambiance. Have you ever walked under a full moon and noticed how colors seem to disappear? That's because moonlight is much weaker than sunlight, and our eyes switch to a different vision mode, more sensitive but less capable of distinguishing colors. It's as if night painted the world in tones of gray and silver. And on very dark nights, far from city lights, the atmosphere reveals another of its secrets, zodiacal light. It's a soft glow that extends along the sun's path in the sky, created by sunlight reflected by interplanetary dust. It's as if we could see the solar system's plane drawn in the night sky. Close your eyes and imagine a journey through time. Not an ordinary journey, but a voyage through light itself. Because each photon that touches your skin, each ray of light that enters your eyes, carries with it a biography, a story of cosmic adventures that lasted millions or billions of years. Let's begin our journey in the heart of a star. Imagine a nuclear furnace with temperatures of millions of degrees, where hydrogen nuclei fuse to form helium, releasing a colossal amount of energy. This energy is born as gamma radiation, extremely energetic and dangerous. But here's something fascinating. This radiation can't escape the star immediately. It gets trapped, ricocheting between particles in the stellar interior, like a ping-pong ball being thrown in a room full of people. Each collision modifies its energy, frequency, direction. This process can last thousands of years. A photon born today in the sun's core might take 170,000 years to reach the solar surface. During this epic journey, it transforms thousands of times, gradually losing energy until it becomes visible light. It's as if the star were an immense temporal filter, transforming pure energy into gentle light. When it finally escapes the stellar surface, this photon begins a new phase of its biography, the journey through space. In the cosmic vacuum, it travels in a straight line at 300,000 kilometers per second, carrying with it information about the star that created it. The light illuminating you at this moment may have different origins and therefore different stories. If you're under sunlight, you're being bathed by photons that were created in the sun's core thousands of years ago, but only completed their journey to you 8 minutes and 20 seconds ago. The time light takes to travel from the sun to Earth, but if you're looking at stars, you're seeing the past even more dramatically. Light from the nearest star, Proxima Centauri, took 4.2 years to reach you. This means you're seeing that star as it was 4.2 years ago. And for more distant stars, you're literally looking at the universe's deep past. Some of the stars you can see with the naked eye no longer exist. They exploded or burned out, but their light continues traveling through space, carrying the memory of their existence. It's like receiving a letter from someone who has already died but who still has something to tell you. Have you ever thought that when you look at the Andromeda Galaxy, you're seeing light that traveled for 5 million years? This light began its journey when the first hominids were just beginning to use tools on Earth. It's an impressive temporal connection. You're connected through light with unimaginable epochs of the past, and each photon carries a unique signature of the star that created it. Light color tells us about stellar temperature. Blue stars are hotter, red stars are cooler. Absorption patterns in light reveal which chemical elements are present in the stellar atmosphere. This is how we know there's iron in stars, oxygen in nebulae, hydrogen in distant galaxies. Each element leaves its mark on the light that passes through it, like a cosmic fingerprint. Light is our cosmic messenger, bringing news from places we can never visit. But starlight's biography doesn't end when it reaches Earth. When it enters Earth's atmosphere, it interacts with our air molecules, being scattered, absorbed, modified. When it touches the planet's surface, it's reflected, refracted, transformed again. And when it finally reaches your eyes, it undergoes one more transformation. It's converted into electrical signals in your retina, processed by your brain, and transformed into conscious experience. Starlight that traveled millions of years through space finally becomes your visual perception of beauty. Have you ever stopped to think that you are literally a starlight detector? Your eyes are refined astronomical instruments, capable of detecting individual photons that made epic journeys through the cosmos. Every time you look at the night sky, you're doing astronomy with your own body. And here's perhaps the most poetic part of starlight's biography. It physically connects us with the cosmos. The elements in your body were forged in stars that exploded billions of years ago. The light from these stars still reaches us, carrying information about the same nuclear processes that created the atoms that form you. You are made of stardust, and you see through starlight. It's a cosmic poetry of connection that goes beyond metaphor. It's a profound physical reality that links us to the universe in ways we're only beginning to understand. Imagine you're in a garden during golden hour at dusk, when sunlight becomes soft and warm. You observe a red flower, its vibrant petals contrasting with the green leaves in the background. But what you're seeing isn't simply a flower. You're witnessing the work of the universe's most sophisticated brush, nature itself, using light as its artistic tool. Each petal of this flower is a miracle of molecular engineering. Over millions of years of evolution, plants developed specialized pigments, molecules that interact with light in specific ways. The anthocyanin that gives the flower its red color isn't just decorative. It's a complex system of protection against ultraviolet rays, an attractant for pollinators, an indicator of the plant's health. Have you ever wondered why flowers are colorful? Why nature invested energy in creating these vibrant palettes? It's because flowers are talking not to us but to insects, birds, other animals. Each color is a specific message, an invitation coded in light frequencies. A rose's bright red isn't accidental. It's a signal for certain insects that can see in this frequency saying, "Here's nectar, here's worth landing." Ultraviolet, invisible to our eyes, creates intricate patterns on petals, like landing strips for bees, guiding them directly to the flower's center where the pollen is. It's fascinating to think there's an entire world of colors and patterns happening around us that we simply can't see. Bees see the world completely differently from us. For them, a field of flowers is like a city at night seen from above, full of luminous signs, each with its specific message. But nature doesn't stop there. It also uses light for camouflage, protection, communication. Have you ever observed how the green of leaves changes subtly depending on the season? In autumn, when chlorophyll decomposes, other pigments are revealed, carotenoids that create yellows and oranges, anthocyanins that produce reds and purples. It's as if nature had a hidden color palette all along, and autumn were the moment it decides to show us its true art. Each falling leaf is a small masterpiece, painted by the complex interaction between light, chemistry, and time. And it's not just plants that master this art of light. Animals also develop sophisticated strategies to manipulate light. The peacock, with its iridescent feathers, doesn't possess blue or green pigments. Instead, its feathers have microscopic structures that interfere with light, creating colors through pure physics, the same principle that makes soap bubbles shine with rainbow colors. Have you ever seen a hummingbird change color depending on the viewing angle? It's the same physical magic in action. The feathers contain nanometric structures that act like tiny prisms, separating white light into its component colors and reflecting only certain frequencies. And here's something that will impress you even more. Some animals can see colors we can't even imagine. Butterflies can see in ultraviolet and have up to 5 different types of color receptors, compared to our 3. For them, the world must be a kaleidoscope of colors our language doesn't even have words to describe. Birds also see in ultraviolet, and many of them have color patterns in this frequency that are completely invisible to us. It's as if there existed an entire dimension of natural beauty that's denied to us by our biology. But perhaps it's exactly this limitation that makes our perception of beauty even more precious. Nature also uses light to regulate biological rhythms. Morning sky's blue light signals to our body that it's time to wake up, suppressing melatonin production. Evening's red light has the opposite effect, preparing our body for rest. We are creatures of light as much as we are creatures of flesh and bone. And plants, they are true masters of light. They not only capture its energy for photosynthesis, but also use different frequencies to regulate their growth, flowering, metabolism. They know what type of light they're receiving and adjust their physiology accordingly. It's intelligence without a brain, wisdom coded in chemistry and physics. There's something almost magical in the moment when a photographer presses their camera's shutter. In a fraction of a second, Trillions of photons that traveled from their distant sources are captured and preserved, transforming an ephemeral moment into a permanent memory. Photography is literally the art of painting with light. Photos means light. Graphos means to draw. But have you ever stopped to think about what really happens when a photograph is taken? It's a process that combines quantum physics, molecular chemistry, and human perception in a way so elegant it seems almost impossible that it works. Let's start with the camera's eye, the lens. Like the human eye, the lens collects light from different directions and focuses it on a specific point. But here's something fascinating. The image that forms on the camera's sensor, or film, is upside down and laterally inverted. It's exactly how it works in our eyes, but our brain learns to flip the image automatically. The lens is essentially a light manipulator. It bends light rays using the principles of refraction, the same physics that makes a straw appear bent in a glass of water. Different types of lenses bend light in different ways, creating distinct effects. A wide-angle lens embraces more light from a wider angle. A telephoto concentrates light from a narrow, distant angle. But here's where the magic really happens, at the moment of capture. When the shutter opens, for a fraction of a second that can vary from 1/4000th of a second to several seconds, light hits the digital sensor or chemical film, and in that moment, light transforms into information. In the case of photographic film, light causes chemical reactions in microscopic silver halide crystals. It's an almost alchemical transformation. Light energy converts directly into molecular changes. Each photon that hits the film leaves an invisible mark, a ghost of light waiting to be revealed by laboratory chemicals. With digital sensors, the process is different but equally fascinating. Each pixel is actually a small light detector that converts photons into electrons. Millions of these detectors work simultaneously, each measuring the amount of light it receives and converting this information into digital numbers. The image you see on your camera screen is literally light translated into mathematics. Have you ever wondered why photographers talk so much about golden light or blue hour? It's because they intuitively understand how different qualities of light create distinct emotional atmospheres. Midday light, coming directly from above, creates hard shadows and stark contrasts. But evening light, filtered through more atmosphere, becomes soft and warm, enveloping objects in a luminosity that seems almost liquid. And here's something poetic. Every photograph is actually a collaboration between the photographer and light. The photographer doesn't create light. They just decide how to capture it, how to direct it, how to preserve it. It's an art of receptivity, of being present at the exact moment when light reveals something special. Great photographers learn to read light like musicians read sheet music. They can predict how light will behave, how it will interact with different surfaces, how it will change in the next few minutes. It's a form of intimacy with physics that transcends technical knowledge and becomes intuition. And color in photography? It's even more complex than it appears. Digital sensors, for example, don't see color directly. They see only different intensities of light. Color is created through tiny filters, red, green, and blue, placed over each pixel. The camera's software then interpolates this information to create a complete color image. That's why different cameras can interpret the same colors in slightly different ways. Each manufacturer develops their own algorithms to translate light into color, creating distinct visual signatures. It's as if each camera had its own visual personality. But perhaps photography's most profound aspect is its power to stop time. Each photograph is a temporal slice of light, a frozen sample of how photons were behaving at a specific moment. When you look at an old photograph, you're literally seeing light from the past, preserved and presented to your eyes in the present. And here's something that will expand your mind. Some of the oldest photographs we have were made with exposures of hours or even days. This means they captured light over an extended period, creating a kind of temporal average of luminosity. It's as if photography could capture not just a moment, but a synthesis of many moments. Photography teaches us to see light consciously. Before the camera, people certainly noticed light's beauty, but they didn't have a tool to study it, preserve it, share it with precision. Photography democratized the art of observing light, transforming all of us into potential students of luminosity. There exists a language that all sentient beings in the universe share, a form of communication that transcends species, cultures, and even planets. This language is light itself. From the ocean depths to space's vastness, light carries messages, information, and meanings that connect all conscious life. Think of fireflies dancing on a summer night. Each flash is a word in this luminous language. I'm here. I'm of your species. I'm looking for you. It's a communication system that evolved over millions of years, refined by natural selection until it became an efficient and beautiful code. But fireflies are just one example. In ocean depths, where sunlight never reaches, creatures develop their own bioluminescence. Jellyfish pulse with blue and green lights. Anglerfish beckon with luminous lures. Octopi communicate through light patterns that run across their skin like moving text. Have you ever imagined what it would be like if we could communicate through light like these animals do? If we could express emotions, thoughts, intentions through luminous patterns? In a certain sense, we already do. When we place candles at a romantic dinner, we're using light to create atmosphere, to communicate intimacy. When we light colored lights in celebrations, we're expressing joy through luminosity. And humans have taken this language of light to extraordinary levels. We developed complex systems of luminous signaling, lighthouses that guide ships through storms, traffic lights that coordinate traffic flow, emergency lights that communicate urgency. Each of these systems is a cultural evolution of the natural tendency to use light for communication. But perhaps most impressive is how we transformed light into art. A painting is, fundamentally, a careful arrangement of how light interacts with pigments. The artist doesn't paint objects, they paint light reflected by objects. That's why the great masters of painting were also masters of light. Leonardo da Vinci obsessively studied how light behaved, creating techniques like sfumato, those smooth transitions, between light and shadow that give an almost mystical quality to his paintings. Vermeer was a magician of natural light, capturing the specific quality of light entering through windows of his era. Monet dedicated his entire life to studying how light changed throughout the day, painting the same cathedral at different moments to capture its luminous transformations. And have you ever stopped to think about how cinema is literally an art of light? Motion pictures are exactly that, images of light and movement. Each frame of a film is a careful arrangement of light and shadow, color, and contrast. Filmmakers are painters who work with temporal light. In the digital age, we've taken the language of light to new territories. LED screens, old displays, laser projectors, each of these technologies is a form of writing with light. When you look at your smartphone screen, you're seeing millions of small points of light being turned on and off thousands of times per second, creating images, text, video. And here's something truly remarkable. We're using light to communicate across unimaginable distances. The optical fibers that carry the internet are essentially tubes of light. Digital information is converted into light pulses that travel through pure glass cables at speeds close to the speed of light. When you send a message to someone on the other side of the world, you're literally sending coded light. But the language of light goes beyond intentional communication. Our bodies also speak through light. The color of our skin contains information about our health, age, emotions. When we blush, increased blood flow changes how our skin interacts with light. When we're sick, pallor alters our luminous signature. And doctors learn to read these luminous messages from the body. X-rays reveal the internal structure of bones. Magnetic resonance imaging uses magnetic fields to make hydrogen atoms in our body emit signals that are converted into images. PET scans track radioactive molecules that emit light when they decompose. Each of these technologies is a form of making the body speak through light. Have you ever thought that when you look into someone's eyes, you're seeing light that ricochets off their iris and pupil? Eyes are called windows to the soul because they're one of the few parts of the body where we can see internal structures directly through light. Eye color, pupil dilation, movement patterns, all of these are forms of nonverbal luminous communication. And on cosmic scales, light is our only way to converse with the universe. Every telescope is, essentially, a giant ear tuned to the language of cosmic light. When we detect gravitational waves from colliding black holes, we're hearing messages that traveled billions of years to reach us. Light is truly a universal language because it's based on the fundamental physics of the universe. Anywhere matter and energy exist, there will be light. And any intelligent civilization that evolves on any planet will eventually learn to read and write in this cosmic language of light. Now, let's dive into one of the most mysterious and fascinating aspects of light, how it transforms into conscious perception. Because seeing isn't just a physical process of detecting photons. It's a complex creative act that happens at the mysterious interface between physics and consciousness. Your eyes are extraordinary instruments, but they're only the beginning of the story. When light enters your pupil and hits your retina, it encounters approximately 120 million rods and 6 million cones, specialized cells that convert photons into electrical signals. But here's the first mystery. Your retina processes this information before even sending it to the brain. The retina isn't just a passive light detector. It is literally an extension of your brain, performing complex image processing before visual information reaches the visual cortex. It detects edges, movement, contrast changes. It's as if you had a microscopic computer in each eye, pre-processing reality before your consciousness perceives it. And then comes the really impressive part. When these electrical signals reach your brain, they're processed by different specialized regions. One area is dedicated exclusively to movement, another to colors, another to shapes, another to face recognition. Your brain dismantles the visual image into components and then reconstructs it as a unified experience. But here's where things become truly mysterious. You don't passively see what's out there. Your brain is constantly creating, interpreting, filling gaps. You have a blind spot in each eye, the place where the optic nerve connects to the retina, but you never notice, because your brain automatically fills this area with information from the surroundings. Have you ever wondered why you don't constantly see your own nose, even though it's always in your field of vision? It's because your brain learned to filter it out, to treat it as irrelevant information. Your visual perception is as much about what your brain chooses to ignore as what it chooses to process. And colors. Prepare to have your mind expanded. Colors don't exist out there in the physical world. They are creations of your brain. What exists are different frequencies of electromagnetic radiation. Color is the interpretation your nervous system makes of these frequencies. This means the experience of red you have when looking at a rose doesn't exist in the rose. It exists only in your consciousness. This raises profound questions about the nature of reality. If colors are mind creations, what else about our perception is constructed instead of detected? Different animals see the world in completely different ways. For a bee, which can see ultraviolet, a field of flowers is decorated with patterns that are completely invisible to us. And here's something that will intrigue you even more. Your brain is constantly making predictions about what you're about to see. Based on past experiences, it creates expectations about how light should behave, what objects should be present, how shadows should fall. Most of what you see is actually these predictions being confirmed or adjusted. That's why optical illusions work. They exploit the assumptions your brain makes about how light and shadows behave. When these assumptions are violated, you see things that aren't there or fail to see things that are. It's a fascinating window into the normally invisible processes of perception. Have you ever experienced that moment when you're looking at something familiar, but suddenly it seems strange or different? It's your brain recalibrating its visual predictions. Sometimes, especially when we're tired or distracted, we can have small glimpses of how our perception is constructed instead of given. And depth perception? It's even more impressive when you consider that each of your eyes sees only a two-dimensional image. Your brain compares the small differences between these two images and uses this information to construct a three-dimensional perception of space. It's a feat of computational geometry that happens automatically without you needing to think about it. But perhaps the most profound aspect of visual perception is how it connects with memory and emotion. The light that enters your eyes doesn't just create images. It evokes memories, awakens emotions, influences your mood. The quality of light in an environment can instantly transport you to another time and place. Have you noticed how certain qualities of light can evoke nostalgia? Late afternoon's golden light can remind you of childhood. A cloudy day's blue-gray light can create a sense of melancholy. It's not just psychology, it's neurology. The same neural networks that process visual information are connected with memory and emotion centers. And here's perhaps the deepest mystery of all. How do patterns of electrical activity in your brain transform into the subjective experience of seeing? How do neural signals become your conscious experience of contemplating a sunset? This is called the hard problem of consciousness, and we still don't have a complete answer. What we do know is that visual perception is one of the most sophisticated aspects of human consciousness. It's a complex collaboration between physics, biology, neurology, and something more, something we still don't completely understand, but that makes you an active participant in creating the visual reality you experience every moment. Long ago, before there were eyes to see or minds to contemplate, light already carried secrets through the universe. Each photon is a cosmic messenger, a time capsule traveling through space, carrying precious information about the most remote places and ancient events of the cosmos. When you look at the night sky, you're not just seeing distant points of light. You're receiving cosmic correspondence, letters written in electromagnetic frequencies, sent by stars, galaxies, and phenomena that perhaps no longer exist. It's like having a cosmic mailbox that receives messages from the universe's deep past. Every star you see has a story to tell, and it tells this story through the light it emits. A star's color reveals its temperature. Blue-white stars are young and hot, burning hydrogen furiously. Red stars are older and cooler, sometimes giant balloons in their final life stages. But the information goes far beyond basic color. When starlight passes through a prism or spectrograph, it reveals itself as a rainbow with specific dark lines. These lines are like cosmic fingerprints. Each chemical element absorbs light at specific frequencies, leaving its mark on the light we observe. This is how we know there's iron in the sun, helium in distant stars, water in the atmospheres of planets beyond the solar system. Light is our cosmic archaeologist, excavating information about the universe's chemical composition. It's impressive to think we can know what a star is made of without ever having touched it, just by analyzing the light it sends us. And it's not just stars that speak to us through light. Entire galaxies have their own luminous signatures. Spiral galaxies emit a different type of light than elliptical galaxies. Galaxies forming many new stars shine intensely in blue. Older galaxies dominated by ancient stars tend to be redder. Have you heard of redshift? It's one of modern astronomy's most important discoveries. When a galaxy is moving away from us, its light is stretched by the movement, making all colors shift slightly toward red. The more distant the galaxy, the greater the redshift. This is how we discovered the universe is expanding. But here's something even more impressive. Some of the photons that enter your eyes when you look at the night sky traveled for billions of years to reach you. They were born when the universe was young, when Earth didn't even exist yet. You are literally seeing the cosmos's deep past. The most distant galaxy ever observed is so far away that its light took more than 13 billion years to reach us. This means we're seeing that galaxy as it was when the universe was only a few 100 million years old. It's an impressive temporal window, making every telescope a time machine. And black holes? These mysterious objects don't emit light, but we can still see them through the effects they cause on surrounding light. A black hole's intense gravity curves spacetime around it, and this curvature affects light's trajectory. It's as if space itself were a lens, focusing and distorting light from stars behind it. Recently, we even managed to photograph black holes, capturing the shadow they create against the luminous background of superheated material spiraling toward the event horizon. It's an image that literally shows the edge of what we can see, the limit where light can no longer escape. And gravitational waves? Although they're not light in the traditional sense, they're ripples in the fabric of spacetime that we can detect. When two black holes collide, they create waves that travel through the universe at light speed, carrying information about events too violent to be observed through ordinary light. Have you ever thought that we're walking detectors of cosmic radiation? Our eyes evolved to capture exactly the light frequencies that are most abundant in stellar radiation. We are literally biologically refined astronomical instruments, capable of detecting and interpreting messages that traveled unimaginable distances to reach us. And it's not just our eyes. Every cell in your body is constantly being traversed by cosmic rays, charged particles that traveled through intergalactic space. Occasionally, you can even see these particles. They're those small flashes of light you sometimes perceive when you close your eyes in the dark. They're cosmic rays interacting directly with your retina. The most poetic aspect of all this is that light physically connects us with the rest of the universe. We're not separate observers contemplating the cosmos from afar. We're an integral part of the cosmic network of light and energy. Every photon that touches your skin, every ray of light that enters your eyes, is a direct physical connection with distant stars, with time's deep past, with the universe's own evolution. There are cathedrals in nature where light doesn't just visit, but permanently dwells, transforming into something that transcends its original nature. I'm talking about crystals, these perfect geometric arrangements of atoms that were Earth's first light artists, long before any eye evolved to appreciate their beauty. Imagine you're in a deep cave, where darkness reigned for millions of years. Suddenly, a flashlight illuminates the walls, and you discover you're in a crystal cathedral. Quartz stalactites hang from the ceiling like cosmic chandeliers, each one capturing and transforming light in ways that defy imagination. But what you're seeing isn't just decorative beauty, it's physics applied in its purest form. Each crystal is a three-dimensional arrangement of atoms organized with precision that would make the best human engineers envious. And it's this precise organization that gives crystals their extraordinary optical properties. When light enters a crystal, it encounters a completely different medium from air or water. Electrons in the crystal's atoms interact with photons in specific ways, determined by the exact atomic structure. Some crystals slow down light, others accelerate it, some divide it into different colors, others polarize it. Have you ever held a glass prism against sunlight and seen the rainbow it creates? This happens because different light frequencies travel at slightly different speeds through glass. White light enters as a unit but emerges separated into its component colors: red, orange, yellow, green, blue, indigo, violet. But natural crystals do even more impressive things. Diamond has such a high refractive index that light practically gets trapped inside it, ricocheting off internal facets before escaping. This is what creates that intense brilliance and color flashes that make diamonds so mesmerizing. Each diamond is essentially a miniature light machine. And here's something fascinating. Some crystals are piezoelectric, which means they generate electricity when pressed, or vice versa. They change shape when an electric current passes through them. Quartz is piezoelectric, and that's why it's used in watches. A small electrical pulse makes the crystal vibrate at a precise frequency, creating a microscopic metronome that keeps time. Other crystals are optically active, meaning they twist the polarization of light passing through them. It's as if light entered vibrating in one direction and exited vibrating in a completely different direction. This property is used in laboratories to study the structure of complex molecules. Have you ever seen a calcite crystal? It's one of the most magical crystals in nature. When you look through it, you see two images of everything, one directly and another slightly displaced. Calcite has the property of dividing light into two rays that travel at different speeds through the crystal. It's as if the crystal created two simultaneous visual realities. And liquid crystals? Yes, such a thing exists, substances that are both liquid and crystalline at the same time. They flow like liquids, but their molecules maintain crystalline organization. When you apply a small electric current, you can reorganize this structure and completely change how the material interacts with light. It's the technology behind all the LCD displays you use daily. But perhaps the most impressive crystals are those that nature took millions of years to grow. In Earth's depths, under extreme pressure and temperature, atoms slowly organize into structures of almost impossible beauty. Purple amethysts, green emeralds, red rubies, each is a geological experiment in light manipulation. An emerald's color, for example, comes from small amounts of chromium replacing aluminum in Barreau's crystal structure. It's an exchange of just a few atoms in millions, but it's enough to transform a transparent crystal into a jewel of intense, mesmerizing green. Nature is the most refined chemistry that exists. And here's something that will expand your perception of time. Some crystals on Earth are older than multicellular life. Zircons found in Australia are more than 4 billion years old. They formed when Earth was still a young and violent planet. The light you see shining in these ancient stones is interacting with an atomic structure that existed before there were oceans, before there was life as we know it. When you hold an ancient crystal in the light, you're seeing the result of processes that took more time than we can truly comprehend. It's like holding a piece of Earth's deep history, a library of light encoded in atoms. And crystals aren't just passive in their interaction with light. Some of them can store light energy and release it slowly. It's the phenomenon of fluorescence and phosphorescence. Fluorite, when exposed to ultraviolet light, glows with vibrant colors that aren't visible in normal light. It's as if the crystal had a secret personality that only reveals itself under certain conditions. Crystals also taught us much about matter's fundamental nature. It was by studying how light interacts with crystals that scientists discovered matter is mostly empty space. Atoms are like miniature solar systems, with tiny nuclei surrounded by electron clouds. Light manages to navigate through these spaces, occasionally being deflected or absorbed by electrons. Have you ever thought that each crystal is like a musical score written in 3 dimensions? The atomic structure determines exactly which light frequencies will be absorbed, reflected, transmitted, or transformed. It's a silent symphony played in electromagnetic frequencies, and each type of crystal plays its own unique melody. And here's perhaps the most poetic aspect of crystals: they grow. Not like plants or animals, but through an equally mysterious process where atoms spontaneously organize into patterns of increasing order. It's as if matter had an inherent tendency toward beauty, a gravitational attraction toward geometric perfection. As our journey through light's nature approaches its end, let's look toward the horizon and imagine how this fundamental force will continue shaping humanity's future. Because light isn't just our history, it's also our destiny. At this very moment, engineers and scientists around the world are developing technologies that will completely transform our relationship with light. Quantum computers that use individual photons to perform calculations impossible for conventional machines. Optical fibers that transmit information at light speed, connecting human minds across continents. Solar panels that capture starlight and transform it directly into usable energy. Imagine a future where our cities are illuminated exclusively by light captured from stars, where every building is covered with photovoltaic cells so efficient they can capture and use even light from distant stars. It wouldn't just be a solution to the energy crisis, it would be a poetic way to reconnect with the cosmos. And future medicine? We're already using light in ways that would have seemed magical just decades ago. Photodynamic therapy, where special drugs activate only when exposed to specific light frequencies, allowing extremely precise cancer treatments. Optogenetics, where we modify cells to respond to light, allowing control of biological functions with light pulses. Can you imagine a future where we can literally illuminate specific parts of the brain to treat depression, anxiety, or even enhance cognitive abilities? Where light becomes such a precise tool that we can activate or deactivate specific neural circuits, as if we were playing a piano of light inside our own consciousness? And space exploration? Light will be our guide and tool as we expand through the solar system and beyond. Solar sails are already being tested, spacecraft that use solar radiation pressure to propel themselves through space. It's cosmic-scale sailing using the sun's photon wind to take us to distant destinations. But perhaps most exciting is how light will allow us to communicate across interstellar distances. When we finally establish colonies in other star systems, light will be the thread that keeps us connected as a species. Messages coded in laser pulses, traveling through space's vacuum, carrying news, culture, love across cosmic vastness. And here's a truly fascinating possibility. What if we learn to manipulate light in ways we can't even imagine yet? Quantum physics suggests light can be entangled where photons can maintain instantaneous connections regardless of the distance separating them. If we master this phenomenon, we could have instantaneous communication across any distance in the universe. Imagine being able to send a message to a colony in Alpha Centauri and receive an instant response, defying light speed limitations through quantum connections. It would be a revolution in our understanding of physical reality and a complete transformation in how we see ourselves as a cosmic species. Artificial intelligence will also be transformed by light. Optical computers that process information using light instead of electricity could be millions of times faster than current computers. Artificial neural networks made of light, capable of learning and adapting at the speed of luminosity itself. And have you thought about the possibility of light-based artificial consciousness? Minds that exist as light patterns traveling through optical networks, capable of moving instantly between different physical substrates? It's a form of existence that would be fundamentally different from ours, but equally valid. But perhaps the most beautiful future is one where we simply learn to see better, where we develop technologies that expand our senses, allowing us to see colors we've never seen, frequencies we've never detected. Imagine glasses that translate infrared radiation into visible colors, allowing us to see heat as a new dimension of beauty. Or contact lenses that can detect ultraviolet radiation, revealing hidden patterns in flowers, clouds, life itself. And as we become a truly cosmic species, our appreciation for light will only deepen. Each new planet we visit will have its own quality of light, determined by the color and intensity of its local star. Sunsets on worlds with different atmospheres will create color spectacles we've never seen. Auroras caused by charged particles interacting with alien magnetic fields will paint skies with completely new palettes. And perhaps, in some distant future, we'll learn that light is even more fundamental than we think. Perhaps we'll discover that consciousness itself is a luminous phenomenon, that thoughts are light patterns traveling through neural networks, that the human soul is literally made of organized light. It would be the perfect conclusion to our journey, discovering that we're not just observers of light, but that we are, ourselves, beings of light contemplating our own nature through the universe's mirrors. And here we are, you and I, reaching the end of this luminous journey that began with a simple question: how does light paint the world? But we discovered that this question led us far beyond simple physics, far beyond basic science. It guided us through existence's deepest mysteries, the nature of reality, our own consciousness. In this final moment of our conversation, I want you to do something special with me. Wherever you are, stop for a moment and really look around. See the light that's present in this instant. It might be a lamp's soft light, a screen's blue glow, or perhaps the moon's silver luminosity filtering through the window. Now, you know this light isn't just illumination. It's information traveling at 300,000 kilometers per second. It's energy that may have been born in a star's heart millions of years ago. It's quantum physics in action, waves and particles dancing simultaneously. It's art, creating the colors you see, the shadows that give shape to the space around you. Do you remember when we began this journey? I asked where you were, what time it was, how you felt. Now, after everything we've discovered together, these questions have completely new dimensions. Where you are isn't just a physical place, it's a specific point in spacetime's fabric, where trillions of photons converge to create your unique visual experience. What time is it? Time itself is relative to light speed. The now you experience is a complex construction created by the finite speed with which luminous information travels from the external world to your consciousness. You're always living slightly in the past, seeing light that took nanoseconds to travel from what you're observing to your eyes. And how do you feel now? I hope you feel connected with the stars that provided your body's elements, connected with cosmic evolution that created the conditions for you to exist, connected with all other conscious beings who share this extraordinary experience of seeing the universe through light. During our journey, we discovered you're not just a passive observer of light. You're an active participant in creating visual reality. Your brain doesn't simply receive luminous information, it interprets it, processes it, transforms it into conscious experience. You are literally co-creator of the beauty you see in the world. And we discovered that light is much more than a form of energy. It's a universal language connecting all conscious life. It's a form of memory preserving information about the universe's past. It's a bridge between the physical world and subjective experience. It's perhaps the key to understanding reality's deepest nature. But here's the most beautiful thing of all. Our journey doesn't end here. Now that you know light's true nature, you'll never see the world the same way again. Every sunset will be a demonstration of atmospheric physics. Every rainbow will be a spectacle of natural optics. Every star in the night sky will be a temporal window to the cosmic past. The light illuminating you at this moment will continue its journey after you close your eyes. The photons that touched your skin have ricocheted and now travel to other destinations, carrying a small signature of your presence. In a certain sense, you've become part of light's biography, a chapter in the epic story of how energy transforms into experience. And tomorrow, when the sun rises, it will literally be a new beginning. New light, created in our local star's heart, will begin its 8-minute and 20-second journey to Earth. This light has never existed before. It will be unique, unrepeatable, carrying its own possibilities for beauty and discovery. Will you remember to look at that morning light with new eyes? Will you remember you're seeing not just brightness, but the continuation of a cosmic story that began with the Big Bang and includes you as a conscious participant? I want to thank you for taking this journey with me, for allowing your mind to open to these mysteries, for contemplating these profound questions about reality's nature. You brought your own light, the light of curiosity, wonder, awakened consciousness, to illuminate these concepts alongside me. Light will continue painting the world long after our conversation ends. It will continue creating colors, shapes, beauty. It will continue carrying information through the cosmos, connecting distant worlds with luminous signals. And you now are a conscious part of this great cosmic symphony. So, when you wake up tomorrow and sunlight touches your face, remember, you're not just being warmed by a star. You're being embraced by the fundamental force that connects everything in the universe, that transforms energy into experience, that allows the cosmos to contemplate its own beauty through your eyes. And here's my final question for you, a question I want you to carry with you as you continue your journey through this world, painted by light. If you knew that every photon touching your eyes carries a personal message from the universe to you, what message do you think the cosmos is trying to transmit to you?